Hello guys, today we are going to continue for the case, we are going to analyze the case number 3, okay? Also, we will going to see the case number 4 and the case number 5, okay? Just like this. We will try to comprise, okay, all this information in only one lecture. So I hope you may just understand what we are going to do, right? So, right. So the case number 3, okay, let us start for the case number 3. This case number 3. So it is when we have a non-homogeneous high-order differential equation like an d raised to n y dx raised to n plus an minus 1 d raised to, okay, d raised to n minus 1 and dx raised to n minus 1 plus infinite, so then a1 dy dx plus a0 y it's equal to x. Now, see here what you're going to do. Suppose we have here, this is case number 3. For case number 3, we have this x there. This x will be equal to x raised to m. Okay? Yeah, will be x raised to m. And, okay, this x will be x raised to m. This is the first thing. And yp will be equal to 1 upon the function of d times x raised to m. So here, what we have to do, that's the question. So for this case, we have to make first this function of d look like 1 upon 1 plus or minus f of d. Okay? F of d times x raised to m. This is the first thing we have to do. Just make this one look like this. Okay? Just try to find your 1 here, and here it must be plus or minus. It's upon the kind of equation you have there. Okay? So plus or minus and do this one. So it means that when this guy is for positive, I will just make this one. Okay? For positive case, I will write here 1, suppose 1 upon 1 plus f of d. Okay? X raised to m. This will be equal to, okay? This will be equal to, no, guess there is no space. I will write down. Okay. So yp here will be, for case number 1, when this is positive, 1 upon 1 plus f of d, x raised to m will be equal to, okay, will be equal to 1 plus, okay, when this is positive, so the sign will interchange. So there is a different or an explanation for that, okay, just applying some Taylor series and this kind of thing. I don't want just to bother you, I just want to go straight to the point, okay? Yeah, just like this. So minus f of d plus, and f of d will increase, okay, by time, plus it goes to infinite, okay, then it goes to infinite, okay, just understand this one, okay, and here x raised to m, and just like this. So you will just interchange the sign like this. First 1 minus f of d plus f of d squared minus f of d cubed plus f of d raised to 4, and so on and on and on. So till you find what we meant, till you find the d that has the same order of this x raised to m. Yep. Now for the second case, here yp will be 1 upon 1 minus f of d, so time x raised to m, and this will be 1. Okay, when this guy is negative, it will be all positive. All of them will be positive. 1, this will be f of d plus f of d square plus, and so on and on, okay, till you get also this honor. And that's the point, okay? That's the point. This is the way we solve. Now, how to solve this one? Then, from here, as this is the function of differentiation operator, you will just apply this function to the operator. It means that you will derive this guy as much time till you get this differentiation equal to 0. And that's the point. Let us solve just one exercise here. I will start solving this one exercise here. This is the point. Just grab it. You can take it. Okay, and that's fine. Okay. Case number 3. This. Yeah, these are the ones. Suppose we have, let me see here. My computer. Okay. Okay, let me start for this one. Suppose we have y double dash plus minus 2y dash plus y, it's equal to x squared plus x. Okay, suppose we have this, and also I will write 3 exercises here, 3 questions here, so that we can be easily done. Okay, so this is the first one. So the second one, I will write here though. What is this? So suppose here we have y double dash, then plus 16y, it's equal to Euler raised to 3x plus x raised to 4, then plus cos 3x. Okay, and the third exercise here, it is well, we can find here 3 y double dash, it's equal to y double dash equal to y double dash minus 2y dash plus 4y equal to 2 raised to x, then plus minus x squared. And the fourth exercise here that I'm going to solve is this one. Suppose we have y double dash, then y double dash and 4y plus 4y, it's equal to 4y 8 Euler raised to minus 2x and plus 4x squared, then plus 2. Okay? Yeah. These are the exercises that we are going to solve here. Okay? So that you can understand a bit what we mean by this fourth case. Nice? See, I will start for this guy. Now that we have this one, the first thing is, okay, we have to understand that here in this case we have to transform the equation, or that we have to transform this in a case like this, f of d, 1 plus or minus in a function of this. Okay, and this is only applicable whenever you have, okay, whenever you have x raised to m as your function on the other side of the higher order differential equation. Okay, now see how to do this. Let us pick up this for the first equation. Okay, so the first equation will be d squared minus 2d plus 1. I'm writing now the, how can I say, the differentiation operator equation. It must be equal to x squared plus x. Now, see, the first thing, find your yc, then find your yp. Here we know that yc directly, I can just directly find. Directly yc will be Euler raised to x, then c1 plus x c2. Okay, because here will be 2 roots that are real and that are equal also. This is 1. So what will be my yp? Yp will be 1 upon, it must be like this, so f of d, then time x squared plus x. Right? How to find this guy? That's the question. We have to transform first the equation, the function f of d. What is the function f of d? This guy. F of d must be 1 plus or minus f of d. Okay? So how to do this? That's the point. So here, yp, okay, just substitute. It will be d squared minus 2d plus 1. And here I've got x squared plus x, right? So if you just, here you have just 1, then it will be easy to you to make this 1, right? So 1, take here out, just call here this 1. Okay, this is like d squared minus 2d plus 1. Okay, then call this 1 here, 1, then plus, okay, in this case, this will be plus, so d squared minus 2d, right? So this is the function of d, and this is your 1. But see, here the question is, whenever you have minus, whenever you have interchanging signal here, you have to factorize the signal here. Factorize minus 1 here, take common minus 1. Okay? So that then, in this case, it will be minus, and this will be positive. So you put this negative down, this negative will be here, and this will be here. Just change them. Okay? When you have like this function is like negative and the other positive, just take this one common, like 2d minus d squared. Okay? Yeah, just do this one. And that's fine. So in this case, it will not behave as the first one, it will behave as the second expression. So we know when we have, okay, when we have 1 minus f of d, this will be 1 plus f of d plus f of d square, and so on and on. Okay? Time x raised to m. Okay? So this means that this yp will be equal to 1 all upon 1, this one. This is the function of f of d. So this is f of d, right? So then this will be equal to 1, okay, plus f of d, 2d minus d square, then plus 2d minus d square, all is square 2. And that will stop here. Then, sorry, no space here, so I will write here down. So it will be then 1 plus f of d, that is 2d minus d square, then plus 2d minus d square, then I will stop here, and I will write x square plus x. Now the question is, at how long, okay, how long you have to go to just discover that you have to stop? Now see, here it is 1, okay, as long as it is 1 minus f of d, so this is f of d raised to 1, f of d raised to 2, and all will be positive because here it's negative. If it were positive here, it will be positive, negative, and so on and on. Now see, the question is, if you see, well here, okay, this expression, when I multiply for this one, I will have here 2d, okay? D, what you mean by 2d? It is like 1, you will apply the differentiation operator 1 time to this function. And here you will apply differentiation operator 2 times for this function. Okay? Why did I extend to this expression? The question is, see, when you extend to this expression, you have this guy raised to 2, right? So if it is raised to 2, what is the higher order for this expression here? For the lower expression, will be 2 also. Okay? So as long as this guy has this, as long as this lower expression of d, okay? As long as this, how can I say, the lowest degree of this operator, differentiation operator, okay, is getting the same order of this expression here, so we can stop, because all terms after him will be with higher order than this expression there. Okay, just like this. Because see here, if I just apply this, if I just like split this expression, will be 4d square minus this time this. This will be like 2 times 2d times d square, then plus d raised to 4. As you can see, this expression has higher order than this polynomial out there. Okay, so that's why I will not need to write all of this expression, because all of this will be 0. When I derive 3 times, because here I will get something like minus 4d cubed plus d raised to 4, and here 4d squared. If I derive this x squared plus x, okay, the order of this polynomial, the degree of this polynomial is 2, and the order of this operator is 3. So if I apply this operator to this polynomial, it will be 0. Okay? Because if I derive 3 times x raised to 2, it will be 0. So that I can write something like this. Whenever you have d raised to n, and here x raised to n minus 1, that will be 0. Okay? Because when this, how can I say? When the order of the polynomial is less or lower than the order of the differentiation operator, then it will be 0. See, check, x raised to 1, okay? If I derive 2 times, how much will it be? It will be 0. And that's the point, okay? And when we have d, okay, like n and n, the order of the operator is equal to the order of the polynomial, then it will be only n factorial. Yeah, n factorial. Now see, here the order of the operator is greater than the order of the polynomial, so it will be 0 for this one and for this one. So here in this expression, I will take only 4d squared. I will forget all about them. Okay? Just like this. So it means that yp will be equal to 1 this times this. Now put this one, this, apply the function to the operator. So it will be x squared plus x, then plus this to this, 2d x squared plus x, then minus d squared x squared plus x. Then here I will take only 4d squared plus 4d squared x squared plus x. And that's the question. That's the point. Okay, you may see, you can see, it's okay. Yeah, you can see this one. So, see, here this, you have this, and you have this, and you have this. Okay, what you're doing, you are just applying, okay, you are just applying the function to the operator. This will be 1, okay, this to 1, this to 1, this to here, to this, and to this, and to this. Now apply the differentiation. So yp will be equal to x squared plus x, this differentiation, plus 2, apply differentiation to this one time. This will be only 2x plus 1. And here apply differentiation 2 times. See, it will be 2 will be only 2 factorial. That will be only 2. And here if you apply differentiation 2 times, will be 0. Here the same will happen. So plus, okay, plus 4, okay, 4 plus 4, plus 4 what? This guy. Plus 4, apply differentiation 2 times, you know that you are going to have only 2 here. Because this will be 2 and this will be 0. Differentiation 2 times of only x, 0. So this and that. So in the end, you can write it like x squared plus x. This and this will be plus 4x. Then this and this will be plus 2 minus 2. And here you get plus 8. Nice. Now from here, just do some basic calculus. This and this will be 5x. And this and this 0. This will be plus 8. So this is your yp. Okay. This will be your yp, and this is your yc. Okay. If you put them together, then you can have the solution for this exercise. Okay? Yeah. Here you have just to be careful just to check the order of this guy and this one. It's okay? Yeah. The rest is the same, and nothing will change. This is for d square because this is the only one that will contain this guy. Other term will be higher differentiation operator, and it will be 0 if I apply to this function. So for this one, you will just play to these 2, okay? 2d times 2 times. So 2 times this and 2 times this. You will get this one and this one. That's okay. Nice. It's done. Let us go for the second exercise. I hope you can just, if you do not understand well for this case, then just try to pause the video and analyze the second one. In the second one, we have like y double dash plus 16y, okay? It's equal to u raised to 3x plus x raised to 4 plus cos 3x, just like this. Now see here, we know that yc, directly I can find just yc. yc here will be what? Will be 4a, okay? This will be u raised to 0x c1 cos of 4x plus ic2 sinus of 4x. Okay? This is yc. Now, how to find yp? 1 upon, okay, f of d. What is f of d here? Here we know this will be d squared plus 1y. Okay? Then I can just write d squared plus 1. Now the function here is all of this. So it is u raised to 3x plus x raised to 4 plus cos of 3x. Right? So the question is now, we are just solving for case number 3. Why do we have the case number 1 and number 2? For practice also. So here we can just directly go. This yp will be this one applied to this, and to that. So I will get 1 upon d square plus 1, okay? d square plus 1, u raised to 3x plus 1 upon d square plus 1, then x raised to 4 plus 1 upon d square plus 1 and cos 3x. Okay? Now, this is the case number 1. For case number 1, just substitute where you have this coefficient of u raised to 3x, the coefficient of x, just put here, and you are going to find directly 1 upon 3 squared, then it will be 10. Nice. If you put here 3 squared, it's 9. So 9 plus 1, it is 10. And this is 3x. Plus, here, there is no way. You have to arrange this, okay, to this way. So here, I can't arrange in this minus way. It is positive. Because here we have 1 positive, okay, 1 positive. So it is positive, this guy. So we are going to have this one. This will be 1 plus d square. 1 plus d square. And d square is the f of d. 1 is the 1 from this formula. We just put it in a simple way. So x raised to 4 plus, here the same. You will just take this guy, and where you find d square, you will put minus 3 square. Okay? It means that this will be minus 9. Put here minus 9. So you are going to have 1 minus 9 plus 1 and cos of 3x. So here, then, 1 plus d square. Okay? 1 plus d square. So how to solve? Now this one is solved. So yp is 1 by 10 Euler raised to 3x plus, how to solve this expression? Now see, just follow the formula. Okay? When this guy here is negative, I will get positive, then negative. Positive, then negative, and so on and on. Okay, so what will it be? It will be 1 minus f of d. It is d square, as it is, plus, then again, f of d square. And this is square. Okay, here I got 4. Okay, 4 is the highest, okay, differentiation operator that can just can be applied to this function. If I apply another one, this will be reduced to 0. So I will stop in 4 raised to 4. Okay, x raised to 4. Then here it will be minus 1 upon 8 cos 3x. Okay, cos of 3x. Now, this is the equation. So what you have to do, see, here it is done. This one is done, but this one you have to apply now the function to the operator, just like this. So yp will be equal to 1 by 10 Euler raised to 3x plus, apply to here, it will be x raised to 4 minus, this when you apply to this, so this will be d differentiation 2 times, and this is this function, then plus d raised to 4 differentiating like this x raised to 4 minus 1 by 8 cos 3x. Okay, then just solve this one and you are done. Yp is 1 by 10 Euler raised to 3x plus x raised to 4. This differentiation will be only 4 factorial. 4 factorial is like 4 times 3 times 2 times 1. This is 6, 24. And here, if you differentiate this guy, first time will be 4x cubed, second time 12x cubed. So this will be minus 12x squared plus 24 minus 1 by 8 cos 3x. Okay, just in a way to organize it, yp can be first the polynomial or first this guy. So 1 by 10 Euler raised to 3x minus 1 by 8, okay, cos of 3x, then come the polynomial, plus x raised to 4 minus 12x squared plus 24. Okay, yeah, this is your yp. And what is your yc? I guess I put somewhere here. Nah, this is your yc. Okay, now this one and this one together will make the solution, right? This is nice. Now let's go for the third exercise. Okay, now after finishing this third exercise, right, so this third exercise, it's more about like you have y bar double dash minus 2y dash plus 4y is 2 raised to x minus x squared. Now see, here you will get this expression. What you have to do here, just see this well, just transform this, find your yc. It will be d squared, okay, minus 2d plus 4. This is y, 2 raised to x minus x squared. Okay, see here then we have to find what is my yc. Just by looking here, I cannot say my yc directly is this or that. Just, yeah, we have to calculate here, no way. So delta will be like 4 minus 4ac, okay? A is 1, c is 4. So delta will be equal to, as you see here, will be equal to minus 12. Okay, so minus 12, it is what we know. So if it is minus 12, it means that we have imaginary roots. So it means that d1 and 2 will be minus 2 minus positive plus or minus root of minus 12. Okay, all upon 2. This one will be equal to 2 plus or minus 2i root of 3 all upon 2. 2 can be cancelled out, so d1 and 2 will be 1 plus or minus, okay, root of 3i. Okay, this is my imaginary root. So yc will be equal to Euler raised to, here I have the real part, 1x time cos of root 3x, okay, no space there. So yc will be Euler raised to x c1 cos of root 3x plus ic2 sinus of root 3 x. Right? So now this is the solution. So what will be the next step? Find yp. So to find yp, here we have, so yp is 1 upon, just write the function, all of them, d square minus 2d plus 4. And here it is 2 raised to x minus x square. So yp will be 1 d square minus 2d plus 4, then time 2 raised to x minus 1 d square minus 2d plus 4, and here x squared. Here we know that we have to apply this formula, the formula for this case number 3. Here it is case number, it's exponential, so it is case number 1, because this one, if you have like 2 raised to x, it is the same as Euler ln 2 raised to x. And here you have Euler raised to what? Ln of 2 times x. This will be my a that I will substitute in the function of d. Okay? Just like this. So then, here, I have to make it a function look like 1 minus fd or 1 plus fd. In this case, it will be 1 minus fd. But here, I don't have 1. That's the point. How to make it 1? So see, to make it 1, you have to multiply and put and take 4 here. So for this case first, you will get something like this. 1 d square minus 2d plus 4, and Euler raised to x, ln 2 times x minus. And for here, you have just to do what? Put here 4 and divide it all by 4. What you are going to have? 1, then plus d square upon 4 minus d by 2. Okay, d by 2, then here x raised to 2. Now see, this is 1, okay, and this is the function of d. Okay, this is f of d and this is 1. Again, minus here, so you have to put minus out. So here it will be the opposite. Here it is by 4 and it is square. Okay, it is square, just like this. It is square. Yeah, by 4 and it is square, and here it is 2 and it is only d. Okay, so in this way, yeah, in this way, x square. Nice. So in this way, now you have this one. This will be your function of d, okay, and this is negative. Okay, just like this. It is just changing when you change the sign. That's okay. Now see, from here, what you have to do, just apply the rule. Go up there. See, what is the order here? It is 2, okay? And just apply here. And that's all. That's all. Let me see whether if I can erase something here. Yes, I can. I do. Okay. Okay. No problem. I can erase this upper part here. So I will have yp is equal to 1 upon. Now see, ln of 2, I will substitute in the place of d. I will get ln of 2 square minus 2 ln of 2 plus 4. Euler raised to this guy. This Euler raised to ln of 2x is the same of 2 raised to x. You can just keep it like this. I just changed it because I needed to know what is Euler to transform this guy and apply case number 1. Then, for the second one, here, now that we know, okay, Now that we know this is 4, we take 4, then we just take common this negative sign, then it changes like this. This is my f of d, and this is negative, so it means that I'm going to have expression like 1 plus f of d. What is f of d? D upon 2 minus d squared upon 4, then plus again d by 2 minus d squared by 2 by 4 raised to 2. Okay? And I will stop here because this is x raised to. It is x squared. Why did I stop here? And here I will take only this expression because all the terms after this expression will have higher order of differentiation with respect to this function. Then it will be 0, just like this. Okay? So then I will just apply this to this, and that's fine. So yp will be equal. Here it will remain the same. ln of 2 squared minus 2 ln of 2 plus 4. Okay, plus 4. 2 raised to x minus, then apply this to this. Here the only term I will take will be d squared by 4. The rest will be greater than this one. Here the differentiation order will be greater than x squared. So I will not take it. It will be 0. This time this, x squared. This time this. This will be d upon 2. Okay? This will be differentiation applied to x squared one time minus d squared by 4. You differentiate this 2 times. Okay? Then plus, here I will just take over this guy. D squared of x squared all by 4. Okay? As you can see, this and this will be 0. Can be cancelled out. Okay? This will be 0. And this is plus. Okay? So, what will be my yp then? Yp will be 1 upon ln of 2 squared minus 2 ln of 2 plus 4 2 raised to x minus, here I will get what? X squared, and here I will get 2 only. 2x, sorry. Plus, it is minus, so it will be minus also. Derivative of x squared, this will be 2x upon 2. 2 and 2 will be cancelled out. I'll get only x. Okay? This will be the solution for this case. Yeah, that's it. Now, we will solve for this one. That is the last one for case number 3. Then we will jump to the case number 4. Right? Nice. Let me just take it out of here. Okay. To the case number 4. Okay, can I erase this one? Nice. It's done. Okay, after finding this yp, then you know that yp plus yc, just put them all together, you have the solution, general solution. Now see, we have this expression here. This is y double dash plus 4y. It's equal to 8 Euler raised to minus x plus 4x squared and plus 2. That's the point, okay? That's the point. Okay, how to solve this? See, here you have to apply also combined case, like case 1, case 3, and then so on. This guy, how to solve them? We know d squared plus 4, okay, y, 8 Euler raised to minus 2x plus 4x squared plus 2. Okay, here we are applying auxiliary equation, so d squared plus 4 is equal to 0. Directly here we can see that yc is Euler raised to 0x c1 cos 2x plus I c2 sinus 2x. Okay? Directly. So yp will be 1 upon d squared plus 4. Then here we will get 8 Euler minus 2x minus 2x, then plus 4x squared plus 2. So yp will be equal to what? Okay, yp will be equal to 8 out. Then you apply this guy here, d squared plus 4 YOLO minus 2x. Okay, plus apply to this one, 4 out, d squared plus 4, and here x squared. Then plus 2 out, 1 d squared plus 4 YOLO raised to 0x. That's the point. So yp here, just substitute here. This will be 8, 1 upon. Substitute here minus 2. It will be 4. 4 times 4, it is 8. YOLO raised to minus 2x. Then plus, here you know, this is 4. This 4 must be 1 for this case, because here, whenever we have, this is equal to x raised to m, we have to change them. This x raised to m, it must be like x raised to m, 1 plus f of d, plus or minus. We have to make it. And this is function of d only. It means that this is a term, this is a function that we have find. We can find only d, okay? And 1 can be out. So for making this 1, to make this 1, you have to divide it all by 4, 4, 4, and put here 4, okay? Just like this. So it is already 4 out, so put here 4, 1. When you divide it all by 4, what you are going to have? You are going to have d squared plus 1, just like this, okay? And here by 4, 1 d squared by 4, and here x squared. 4 will be 1. Nice. Then what else? Plus, put here 2. Put here 0. If you put here 0, what you are going to have? 0, 4 only. So this will be 2 by 4. YOLO raised to 0 is 1, so no need. This and this you can just simplify. It is 1 by 2. So yp, this also will be simplified, minus 2x. And this guy, this will be got this one, plus 1 by 2, then plus this expression. How to solve this expression? That's the question. That's the point. How to solve this expression? Now, this is f of d, and this is 1. This is plus. When this guy is plus, we know the sign will interchange. Will be 1 plus, 1 minus f of d plus f of d square, and so on and on, time x raised to m. So then we know that here I will get 1 plus f of d squared by 4, okay, negative, sorry, plus f of d again by 4 raised to 2. So stop here and just put here x squared, okay? See, d raised to 2 to 2, d raised to 4, x squared. The differentiation order, okay, is greater than the function order or degree of this function. So this will be 0. If I apply the differentiation operator to this expression, to this function, this will be 0, because 4 is greater than 2. But if I apply to this one, it will be only factorial of 2, because 2 and 2. Apply, differentiate this guy 2 times. Okay? So this one will be yp YOLO raised to minus 2x plus 1 by 2. Okay? 1 by 2. And plus this time this will be x squared, and this time this will be minus differentiation 2 times of x squared by 4. Here we know this will be 0, because d raised to 4x squared, okay, by 16, this all will be 0, and this will be only 2. So yp is YOLO raised to minus 2x plus x squared, okay, plus x squared minus 2 upon 4, and here I will get plus 1 by 2. This and this will be cancelled out. This will be 2, 1. So this and this is 0. So yp will be YOLO raised to minus 2x plus x squared. Now that you know your yp, just put together with your yc, this one and this one, and this is the solution of your case. Okay? Done. We are done with the case number 3. Now we are going to start the case number 4. Okay? Then after case number 4, we are going to jump to solve variation parameter and also the other exercise. The other method to find PI, that is, I just forgot, but it's okay. We are going to cover this one. Okay.